Welcome. Back in time, in 1986, a commercial won a Golden Lion Advertisement Award. That commercial has been showing Great Britain of 1980s. And it starts with the camera rolling in and showing a young man, a skinhead, getting spooked by police maybe and starting to run. And then a second camera rolls in and it shows the same young man running up to an old man, grabbing his briefcase and wrestling the old man to the ground. And finally, the third camera rolls in and it shows us that young man was actually saving the old man's life from a falling construction platform. It ends with a very powerful message. It says, unless you have a full picture, you can't really understand what's going on. Any partial perspective would have led to a very wrong conclusion about the same theme. And that's why it had such a powerful message to win the award. My name is Igor Sedukin. I'm a general manager for application observability in AWS. Joining me today on stage, I have Siva Guruvarediyar, a solution architect at AWS, and Brian Link, who's a director at PBS. Together with you, we'll explore the interesting topic of a full picture of application observability. At Amazon, at AWS, our builders take pride in operational excellence. It is a big part of our business results is that excellence and being able to operate at scale and being excellent operating the services. We've been building this whole picture. Our engineers have been building a full picture so that we can make right decisions ourselves about what is going on in our services. It takes multiple perspectives. It allows us to see full picture. It leads to good decisions expediently. And we've been building it at scale so it can work and serve our needs. The way we built it is cloud first. What does that mean? Number one, the observability we build must be resilient, must be available when anything else is down. That's the first condition. Otherwise, you can't observe another application, another service. Number two, it has to be efficient at scale, or else our bottom line is not going to be that good. And it needs to support all variety of scales from low to high and scale with your needs elastically. So last year, at reInvent, we launched a full picture tool in CloudWatch. It's called Application Signals. This tool embodies a lot of operational practices that make us and our engineers be efficient, and we hope it makes you and your engineers productive and efficient as well. This is the tool that allows you to see a big picture and then make the right decision about what is going on and why it matters. Let me do a quick overview of how this tool and what practices it encompasses. So there's three things you would do with it. Number one, you understand that full picture. Just like the commercial I gave, any partial perspective would have led you to a wrong decision or wrong conclusion. Number two, once you spot an anomaly in your full picture, you can diagnose and determine the root cause and why that anomaly exists, but only after you know it matters. Number three, this tool allows you to incorporate additional perspectives. They're very important to determining whether the full picture is actually truly full and truly representative of your customer experience or your end users. So to understand the full picture, there are three entry points that you could use. Number one is service level objectives. This is where you can make selection of a set of things that matter to you whether it's the latency of your API or whether it's ability to create an object or ability to do something that your customers value. You may want to have an SLO, service level objective, to assess whether it's working well or not for your users, right? Number two, you can use Service Dashboard that gives you a full overview across all the services you have. It also includes information about dependencies you may have. If any of your dependencies are having high latency, you may want to know that first. You may want to incorporate that in your picture, in your decisions. And number three, it has a service map. Allows you to see a full topology of your application, and then any connections and any health issues that you may encounter in the full picture of your application, right? Once you spot any anomaly there, you would typically do a service diagnosis, which includes spotting an anomaly in your P99 of metrics and then getting precisely the transactions that cause the P99, and then getting the root cause of why those transactions are causing the P99 latency. Number three is a set of other perspectives. So you can incorporate perspectives such as synthetic, outside-in perspective, modeling the customer workflows and understanding whether they work against your service. Another one is real user monitoring, understanding whether the websites or other applications that work outside, load in your browser, not in your servers, are actually experiencing any issue because your service is not performing well. Very typical one is knowing, for example, that you have 400, not HTTP 500 errors, but 400 errors, where they matter to the customer when they enter a value, but they don't show up in your service diagnostics as faults, right? And a third thing you can do is you can incorporate information about resources that your application is running on. For example, containers or a Lambda that it runs in, right? So you can incorporate information in the same full picture so you understand whether your application is having stress because of memory issue, right? This tool integrates metrics, logs, and traces into one full picture about your application. And it also provides standard out-of-the-box metrics that every application should have about its APIs and dependencies, right? So we launched that tool. We made it available earlier in the year. And we've been busy adding a lot of things that you've asked us to have in that tool. So there are a couple of new things we're releasing now at this reInvent, adding to the tool. Number one is transaction analytics. So this allows you to capture 100% of your application transactions at a very reasonable bottom line, and then do analysis on them. And it's designed to make sure you don't miss unique anomalies with your end users when average is okay, but one of your customers has P99 latency and you need to know about it, right? So this ability to capture and analyze transactions is very useful to spot anomalies like that, as well as your ability to support your customer. When customer is on the line and they tell you the order number, you better find that order and what happened to it. We've added another capability that was announced earlier in reInvent. Amazon Q Developer Operational Investigations. So it's now integrated with this tool. So when you have a service level objective breach, you can very quickly let GenAI figure out what happened and why it matters. Our tools and our solution is fully OpenTelemetry based. We have our agents, we have our SDKs, everything is based on OpenTelemetry. This year, we've added OpenTelemetry endpoint, so you can send data to us directly and in a much easier manner. We've expanded our service level objectives to support volume-based assessments. So if you have a lot of requests or a lot of customer activity, we can adjust service level objectives when you have a lot of requests. We've incorporated a runtime metric, so it allows you to know that a transaction stress or some latency is also correlated to potentially a garbage collector getting really hot on a particular node, it correlates the runtime metric and the application metrics together. We've expanded language coverage to Node.js and .NET. With OpenTelemetry, you can use other languages as well, but these are, we provide automatic out-of-the-box solutions for. We've integrated with Lambda. So out of the box, you get a full application observability for your Lambda. Think of it as embedded OpenTelemetry inside of Lambda, without having to pay cold start cost and without having to install any agent or any other solution, right? We've expanded to database support. So you can now spot an anomaly in an application, service level objective, or an API performance, and deep dive into the reasons that may end up being database query performance and lack of indexing, right? We've expanded our support to cover generative AI analytics inside of your application. So you can tell which model is performing better for you in your utilization of generative AI, Bedrock APIs, and models. We also expanded real user monitoring to all regions, all commercial regions. So now it's available in the same place where the rest of the application observability solution is available. So this is what we've done so far, added to this year. Now I'm going to invite Siva to the stage and let you see it all in action.
Yeah. Hi, everybody. Thank you, Igor, for the great overview. My name is Siva Guruvarediyar. I'm a senior specialist architect focusing on observability. And welcome to the session. Hope you are enjoying your reInvent. And today, I'm going to talk about some of the features that Igor was talking about. So the demo is about a pet clinic application. So our demo is continuing from our last year reInvent. It's basically I'm a service operator running this pet clinic. So from this one, I wanted to make sure my customers are happy. So why do I care about application signals? Because we have been investing heavily on application signals for my day-to-day operations. And I will be showing you some of the scenarios that I'm using as a service operator to run this particular application, and then to making sure my customers are going to be happy with that. So with that one, this is the pet clinic application. And this is people can book their appointment, get their pets for any kind of issue resolution. And also they can go and update their insurance information, billing details, a typical pet clinic application, right? So with that one, show me your hands if you are using Lambda and you want to make sure your customers are happy. Everybody, right? Because we all want our customers to be happy. So currently I have an appointment service which is running in Lambda, and I wanted to make sure it is available 100% of the time. And I created an SLO on this. It's called appointment service availability. And currently it is running unhealthy. And we wanted to know what is the root cause of all this. So let me get into the details. So here we are seeing the request and availability chart. And then when I'm hovering over it, it's showing the availability as 91%. But we wanted to go to 100%. So what's going on here? So from the metrics, looks like it is having 8% fault. Why it's having 8% fault? So let's go and look into the faults and errors chart where we are seeing some anomalies. So just click on any of the peaks or valleys, and then this is going to be listing all the transactions for you. So from the looks of it, we are getting so many 500 errors. So before getting into the weeds, let's take a look into the top contributors. And then I'm sorting by versions. And from here, I'm running two different versions of the Lambda, version 6 and 5. And looks like all the faults are coming from the latest version of the Lambda. Again, show me your hands, if you are running something and everything is going good, but suddenly, there are some changes happening and then things start to break. We are all seeing on a day-to-day basis, right? It is coming in our tech life. So now we figured out, the latest Lambda is the root cause, but we have not figured out, why it is happening. So let's go to the correlated spans and then see, we are seeing, a list of transactions. Let's take randomly, any transaction. So this is going to be showing you the trace details page. From here, you can see a lot of information. For example, like, it will show you the map, like, each and every hop, like, how it is going up, and also, like, the spans timeline at each and every hop, how much time it is taking, and also the logs. Everything is available in from one place. So currently our interest is on the appointment service get, and then if I go to the exceptions tab, and that's it. We are getting a null pointer exception at line number 27. As you could see here, we are able to see the root cause with just bunch of clicks. So not only we are able to figure out the latest changes of the problem, but also, like, we were able to see without opening the code or, like, ID or anything, we were able to see at the line level why it is happening. So now I can ask my development team to revert these latest changes and then fix this one and then push it so that my customers can book their appointments, right? But the story doesn't end there. If it is happening for null pointer exception, why it is happening for all the requests? Why it is specifically looking for something, right? So let's go and figure out what is happening here. So if I go back to my service operations page, so from here, like, I'm seeing a lot of requests coming in and then availability chart, etc. You see the blue line, right? So this is going to be showing me all the requests. Basically, if you are seeing here, these are all the different requests, and then I can group by users. So owner ID is my user. So from here, like, as you could see here, there are a bunch of users who are all transacting with the system, and it's like, it's in double digits, right? It's minimum is 16 and maximum is 19. And we wanted to make sure, like, how many of them are getting null pointer exception, right? You rinse and repeat the same exercise with a false and errors thing, right? Now I can go and do this one in the false and errors, and then as you could see here, each and every user, how many of the time they are getting this null pointer exception. So all these things, like, I can bundle up and then give it to my development team so that they can fix it, and then the Lambda is going to be running smooth, right? So with that one, like, let's go to the next scenario. So again, show me your hands if you are running databases in your application. It's a pretty dumb question, right? Everybody is running databases in your application, but the question is about not running it, how you are monitoring it. Because we are doing, like, a piecemeal monitoring, right? You are doing your application monitoring as one piecemeal and then database as another piecemeal. So how life easy it would be if you are able to, like, correlate from your application to the databases or vice versa, right? So that's what we are going to see. So currently I have another SLO created. So my billing service is running, and I wanted to make sure this particular latency of this billing activities, no matter how many transactions are there, it should be 300 milliseconds or less. My latency, like, 300 milliseconds is my mark. I cannot go beyond that. So currently, like, it is running unhealthy, and we wanted to know, like, why it is happening. So again, I'm getting into the details. From the charts perspective, I'm seeing, like, there are requests coming in, there are no faults, but my latency is all over the place. It's going, like, as high as 1.5 seconds, which is not acceptable, right? So with this one, like, let me go to the dependency section and then click on that dependency, and then it will show you, like, what dependency we are running. So we're running a Postgres database, and from this one, like, the select operation itself is taking almost or more than, like, 0.5 seconds, which is too bad, right? And also from the latency, I can easily correlate. Whenever the service fails, there is also, like, Postgres database also something going on over there. So let's go and see there, right? So let's click on this blue link, which is my Postgres operation, and then in the right hand side, you are able to see view in database insights. So database insights is a newer feature which we just launched in this reInvent. So using this, like, you will be able to know what is going on in your database, right? So now I'm going there. I'm just running a single instance cluster, get into the Get Database Insights tab, and then from the top SQL, so this is my select query, right? I have not opened my IDE or anything. So from this one, like, I know exactly what exactly the SQL query that I'm running here, right? So from here, like, it says we are reading all the billing information from billing service table, and also, like, we have been doing some joins with this checklist table. I know because as a product owner, like, I've been talking to my development team. I know they have been doing this change, but looks like the DBAs have forgotten to create an index on it. So now I can call up the DBAs and then say to them, like, go ahead and then create this index. And also, like, I can double confirm this, go to the database telemetry tab, and then there are slow queries. So from here, I will be able to see all my slow queries. The topmost is my select query, and then this one is going to show me how many times it is coming up, what is the average latency, etc. So now all this information I can give it to my database team and then ask them to fix it. But you might be asking the question. So in the starting, you mentioned how we are going to bridge the gap between application layer and database layer, right? And that's where this calling services come in. So assuming I'm a DBA, I'm coming to database insights, and then I'm seeing from here what are the different calling services. So from this one, it is going to list down all the services that are calling my database. So currently it looks like only billing services calling, and I can go ahead and then sort it by average latency, and if in case I wanted to see what's going on in my put operation or create an SLO or anything, just click on it and then it will take you back to application layer. So this way you can go from application layer to database layer or vice versa very easily with application signals, right? So let's go to the next scenario. Again, show me your hands if your management is asking you to explore GenAI or or integrate that into your existing applications, because GenAI is a new norm, right? So we wanted to do it, but once you integrate it, how you are going to monitor it, right? So that's a big question we need to resolve. So in our pet clinic application, so we don't want to leave behind. My team has already integrated GenAI into my application. For example, I can go to my services, service map. I can quickly show you this. So I'm using my customer service to provide some recommendations using Bedrock runtime. So Bedrock is the GenAI service from AWS, so that's what I'm using in my application. So when I'm using that, so currently the customer service is calling the Bedrock runtime. And let me zoom out a little bit. So today I'm using two different models. So one is, there is a Titan Text Express model from Amazon, which I'm using to recommend my customers what are the various diseases that is happening for the pets, right? And also I'm using another model, which is a Claude model from Anthropic. So that one I'm using to making sure what are the preventive steps they have to do it in order to not to get those diseases for their pets, right? I want to recommend my customers. So things are looking good, but if you look closely, my model is taking almost 8 seconds, the average latency for Titan Express, and then for my Claude model, it is taking more than 10 seconds. What's going on here, right? So let's go and look into it. So we are coming in this, and then from here, it's even terrible. My P99, it shows 48 seconds. And then my P99 for Claude model, it is almost 17 seconds. I don't want my customers to wait for 48 seconds to get a recommendation. This is not acceptable, right? So let's solve it. What is that? We are passing to the GenAI model, and then what is that? We are getting back. So this time, let's go into the details. So from here, you can click on any of these particular sections, and then from here, I can go to the transaction. And this time, we wanted to know the logs. So for that, I want to get into the below section and then go to the CloudWatch log insights. So I don't have to type any queries. Everything is pre-populated for me. And then I just click on run query. So this will be showing me all the different logs that is happening at that particular transaction, right? So you just go to this particular thing, and then from here, we will be able to see where is our log is happening, right? So this is our Claude log. Let me also take down the Titan Express log. So this is our Titan Express log, right? Let's see that. It should be somewhere here. Okay, so let's take a look into it from the Claude model, right? So from this one, we are invoking the Claude response. The model ID is Anthropic. And then this is a prompt we are doing it. What are the best preventive measures for my common cat diseases? Looks like this customer is having a cat, and then we are recommending them what are the common diseases for the cat, and then what are the preventive measures that they need to do it. So it's giving them a lot of information, but this might not be useful. I don't think this is useful for them, right? Because I wanted to give them not quantity wise, I wanted to give the quality recommendation. So now I can call my ML engineer ask them to change this particular prompt query, and maybe like during that particular time, they need to work on it to making sure like the latency is reduced, so that it's going to be easy for them where when the customers are looking for any kind of recommendations, they don't have to wait for like 40 seconds or etc. to get those recommendations, right? So with that one, like with application signals, using GenAI and then monitoring those GenAI use cases is going to be like really easy for you. You don't have to do anything like this, like all these plugins are already imported for you. So let's move on to the next scenario, right? Again, show me your hands if you are a support engineer or like you're responsible for answering your customer queries whenever like they are calling up and all those, right? So this is always like finding a needle in a haystack. So the customers can call for anything. So they can say like, hey, my order is not going through. Hey, the website is so very slow. Hey, my credit card is debited, but the order is not coming. The order is delivered to the wrong place. So, but you as a support engineer, you should be responsible and then making sure like you are giving them a proper response in a very less amount of time. So it's always like finding a needle in a haystack, right? So how we are going to approach this with application signals as your APM solution. So let's do that. So currently, I'm a support engineer for my pet clinic application, and I'm getting a call from a customer called Susie. So her ID is 6, and then she's saying like, okay, my order is not going through, and then help me with that. So all I know is just an order ID, nothing else. And she wanted to know like what's going on, and then she wanted an answer, and she's on the line. So how I'm going to approach this? So for this, like under X-ray traces, you can go to transaction search, which is a newer feature which we just launched a couple of weeks back. So you can use this to search your transactions. So currently we know only the order ID. So I can only I can put this order ID, whatever the order number I got from Susie, and then I just say run query. So with this one, like so let me choose like the last 12 hours, right? Because we don't know when she placed an order, and then when we are clicking on it, it says like there are 2 different transactions that are coming in. First one is a payment service. You can see that under service tab, it's a payment service, and second one is a audit service. So let's go and look into it, like what's going on in the payment service, right? And as usual, you will be given a lot of information, starting with the map details and the span details as well as log details, right? So let me zoom out a bit so that you can easily be able to see that. Hope this is good. So what is happening here? My front end is calling the payment service, which is responsible for making sure the ordering flow goes good. And then payment service being a microservice, it is calling other services. For example, it is calling customer service to get the customer information, insurance service to get the insurance details, and then finally nutrition service to order the nutrition that the customer is interested, right? And then I'm seeing like this customer service Java, it's showing as a red node. What's going on there? So let's go and click on this, and then go to the exception, and then we are having a 404. So 404 is a client error. It's basically saying like it's not found. Whatever we are looking for is not found, and the message it's saying like the nutrition information that Susie is looking for is not available. So now I can confidently tell Susie like hey, whatever the nutrition information you are looking for is not available. So can you consider like instead of X, do you want to do Y, etc. And then I can close out the call. But wait a second, Susie doesn't need to call me as a support engineer. This should have been easily resolved in the UA layer as a validation issue, right? So I could have easily validated it when Susie was placing an order, and then I could have checked it and then said like if it is not available, tell them it is not available, or provide some recommendations, right? So I don't want another customer to call me for the same issue. So now I can say to them like maybe I can give this information to my development team, ask them to fix it so that not another customer is going to get a call and then saying like hey, something is not available, and then it is missing out, right? But the story again doesn't end there. I'm wearing my business hat, and then this is happening in payment service, which is crucial for my day-to-day operations, correct? So let's go back and then see whether it's an isolated case or it is happening for many users. Because if it is happening for many users in the payment service, there is something serious going on. So I need to alert my team and then making sure like they are fixing this on an emergency purpose. But before that, I need to make sure is this an isolated case or it is happening for many users, right? So with that one, let's go back to the same place where we came from. So this time, instead of going to the trace details, we are going to the service. So go to the payment service, and under service operations, for the last maybe 3 hours or 12 hours, we can choose it. We can choose what are the requests that are coming in. Again, you can filter by users. And then as you could see here, at least there are 5 different users that are transacting in the system. So how many of them are impacted? So for that, we know we need to go and look into the faults and errors tab. But wait a second, is this a fault or is it an error? It's definitely not a fault because service is not saying service unavailable or it's not throwing any error or something. We just saw this is a 404 error. It's a client error. So we need to look into the orange chart which shows the errors and then click on the anomaly here, right? And from here, again, do the same thing, the owner ID, and then it's showing there is only one person impacted, which is the same Susie from where we got the call from, right? So now we isolated the case. It's an isolated case. It's not happening for all over the customers. So this particular feature will be useful, not only resolving your technical issues, but also for your solving your business cases as well, like this. How many users are impacted, which users are impacted, and all those things. And maybe if Susie is a premium user, then you can call back and then give her some credits to get her loyalty back, right? So those kind of things are easily done using application signals. So with that one, let's go to the last demo for the day. So best is for the last, right? So again, show me your hands if you are doing all these things so far with manual things. You are creating a SLO, and then if SLO is getting breached, your SRE team getting notified, and then you're coming here, clicking on all those things, figuring out the root cause and all those. But how life would be easy if in case a robo can do the job for me instead of I'm doing as a manual work, right? If a robo can help me doing all this work for me, how easy my life would be, because I can look into something else productively, right? So I don't have to do all these things on a daily basis. So that's where your Amazon Q developer operational insights come in. So for this, I have another service. So I have a feedback receiver. So this is a Lambda from which I'm collecting all the feedback from my customers. And then I'm sending that to a Bedrock runtime model to classify that as positive, negative, or it's neutral. If it is positive or neutral, I'm happy because my customers are happy. But if it is negative, I don't want it to leave behind. I just wanted to follow up that with the customer and then making sure they are also happy as well. So for that, I will be calling a ticketing system, another Lambda, and then making sure this entire flow goes good. In case of negative thing, I want to call this ticketing system, create a ticket, follow up with the customer so that everybody is happy, right? To making sure this particular feedback receiver Lambda is working good, I created a SLO on this. So availability on the feedback service should be 100%, but as you could see here, it's currently unhealthy, and we wanted to understand why. But instead of doing the traditional way of doing things, now we are asking the robot to do it. Amazon Q is going to do the job for us. So from the faults and errors tab, we are seeing some spikes. So there might be some issues with the faults coming from the service, but we don't know, right? So now I can click on this unhealthy and then click on this investigate. So I can either start a new investigation or I can add it to an existing investigation. So both of options are available. So I can just say add to an existing investigation if already going on, and that's it. So this is going to take some time, but in the interest of time, I already ran this exercise for you. So if you go under AA operations, under investigations, the same kind of thing is already, I ran it for you guys. So this is what Amazon Q developer is saying. It basically says feedback receiver Lambda experienced a fault due to a timeout error. And then it says the ticketing system Lambda is taking more than 3 seconds. And then finally it says there is a cold start issue. To summarize what happens is here, so there was a negative review from the customer, and then the feedback receiver tries to call the ticketing system Lambda. Ticketing system Lambda was called, and then it is actually calling, like, and it's taking more than 3 seconds, and by the time, like, the ticketing system Lambda responds, the feedback receiver Lambda already timed out. So this is what is happening. So this is what Amazon Q developer is saying. But you might be asking the question, how can I trust this guy? It's saying, like, some bluff thing, right? How can I verify that whatever it says is valid? For that, like, you can click on the show reasoning, and then you can go to the trace tab, because the data cannot lie here. In the span timelines, if this is what is happening, from the span timelines, looks like this particular ticketing system Lambda is taking 3.67 seconds. So Amazon Q developer is not only saying that whatever is happening here, and it is also recommending the next steps of action. For example, it says the ticketing system Lambda, you might increase a timeout, or, like, in the feedback receiver Lambda, you can create a provision concurrency, or the reverse way, right? You can either create a provision concurrency for ticketing system Lambda so that it doesn't go cold, or, like, increase the timeout for the feedback receiver Lambda, which is a calling Lambda, so that it is not timing out. So with this one, like, assuming my development team doesn't even know what is a cold start issue is. So this might have easily taken a couple of hours or even days for my team to realize what exactly the problem is, and then they might be taking maybe days to resolve this. With Amazon Q developer operation insights, whatever it could have taken like a days or hours, in just minutes, like, you should be able to do it with the steps on all those things. If your development team doesn't know about cold start and all those things, you can open up your queue, Amazon Q, and then just start typing, like, what is cold start, and then it will teach your development team what exactly the problem is, right? So those are all I have for the demo. So to summarize, like, with application signals, you can create your SLOs in a proactive manner, and then if there are any issues in production, with just bunch of clicks, like, you should be able to identify a root cause even at the line number level. And also with the help of Amazon Q developer insights, like operational insights, you should be able to do whatever the operation, like, mean time to detection or mean time to resolution in a couple of minutes. But don't take my word for it. We have Brian Link, who is coming from PBS, who wanted to talk about, like, how application signals and then CloudWatch in overall is helping them, like, on their day-to-day operations, and how it is helping them reshaping their observability journey. So without further ado, let me ask Brian to come onto the stage and then share his experiences. Thank you so much.
Thanks, Eva. Hi, everybody. I'm Brian Link, Director of Technical Operations here at PBS. For those of you who aren't familiar with PBS, PBS is a nonprofit public media television channel located here in the United States. If you're familiar with the BBC over in the UK, RTE over in Ireland, the CBC up in Canada, we're kind of in that same ballpark. So we provide tons of inspirational and educational content to folks around the country. We have approximately 180 or so stations located throughout the United States. So just a little background before we dive into some of the problems that Application Signals has helped us with. Our station video portal is basically just a station branded version of our pbs.org website. So our local stations all produce their own local content for things pertinent to their area. As you can see over here at the top, Idaho PBS has a show called Outdoor Idaho that they are featuring in this particular case. Down at the bottom, about a month ago, we had an election here. Arizona PBS opted to put together a program on just all of the various local races and things that are pertinent to the folks in Arizona, but not necessarily going to draw a broad national audience. Station Video Portal relies very heavily on several of our APIs, including our Stations API. That Stations API is a pretty basic microservice. It's just providing some metadata about those approximately 180 stations. Things like donation links, the logos for that particular station, sending folks out to their social media entities that they have, et cetera, et cetera, et cetera. So this all kind of starts with a little bit of a mystery, right? Raise your hand if you've ever been on call and had a PagerDuty alert go off at 3 o'clock in the morning and you've been miserable about it. Yeah, good show of hands. Me too. It's not fun. So a pager goes off in the night. So what you can see here, approximately 3:30-ish in the morning, we see a massive, massive spike in traffic on our station's API. Response times are very slow, error rates are high, et cetera, et cetera, et cetera. And as you might imagine, 3 o'clock in the morning, not exactly our prime traffic time. So what's going on here? Well, after we did some work and we just helped the station's API scale up to handle the traffic and everything subsided back down, we started diving into the metrics in the past, and we started discovering a little bit of a pattern. Every hour, you can almost set your clock by it, there's just a pretty big spike in traffic that happens to the station API, and then it comes right back down. Lasts for about a minute or so. So, this is super frustrating. What the heck's going on here? What are we doing? Well, as my pal and my neighbor, Daniel Tiger, might tell you, when you're feeling frustrated, take a step back and ask for help. Any of the parents in the room might know exactly what I'm talking about here. So what you do is, at least in the beginning, you look for the helpers. Some of the things that we kind of already had in place within CloudWatch are metrics, our log insights. Metrics are great, but they can't really tell you that whole story here, right? So this is that same graph. It doesn't take a genius to tell you that there's a problem going on over here, but it doesn't tell you why this problem is happening or what the root cause of this problem is. So maybe you start diving into your logs. Logs can be great to a point, right? I can look at the logs and start doing some queries and try to identify those URL patterns. Unfortunately, in this case, because this is a small microservice, there's really only like 1 or 2 endpoints for this service. So you're not really able to just kind of differentiate what's going on based on that. You might try to analyze the IPs, but unfortunately this is private IP to private IP. And so my requesters are coming from elsewhere in the same VPC, and actually that station video portal is struggling too. So it's scaling up, scaling down, scaling up, scaling down, containers are dying, those IPs are ephemeral, and you're just not going to be able to easily trace that back and figure out what's going on. Another thing you might think about looking at is something like your user agent in the logs. Totally useless in this case. We are primarily a Python shop. We're doing a lot of Python requests, and all the user agents are Python requests. So you can't really easily just jump in and say, well, it's definitely you. So what do we do? Well, we had just recently embarked on our own journey into application signals. So this chart on the left here is our service map, and we were very quickly able to just kind of hone in and zoom in on that station API and see who all the consumers are and just eliminate a whole bunch of suspects off of the roster there, right? I don't need to worry about my Apple TV app, my Roku app, my Android app. They're not consuming station service. Looks like in this case it's only PBS.org, PBS.org Lite, and the station video portal. And when we dive in a little bit more on station video portal, we're very quickly able to see, hey, here's where this huge spike in traffic is coming from station video portal to the station API. What's going on here? Let's take a deep dive. So we click in on maybe some of these latency traces over here on the graph, and we're able to quickly see that, hey, here's the page getting loaded for the station video portal, and down towards the bottom here, we are calling station services. It is a large paginated query. Each one of these calls is taking about 500-600 milliseconds, maybe more. And that's what's really slowing things down and making it so that these responses are taking a very long time and driving all this traffic. So what's happening here, right? Well, as it turns out, when our station video portal up at the top, it's a very simple app. It's just an ALB, an ECS service, and a Redis cache to cache some of these station API calls and some other API calls. And down at the bottom here, we have our station API, which is pretty much just an ALB and an ECS service. When things are happy and everything's working great, you have this short window of time from when the cache expires to when the cache is populated, where every single request into station video portal is now going to try to refresh that cache for the station API. And it's not that big of a deal here in this particular scenario, 500 milliseconds, the users are fine. The viewers like you are all generally pretty happy here, right? But what happens if Station API is just maybe a little bit stressed out, just having a tough day, kind of like me? Well, now that window of time that you have there is getting larger and larger. Instead of 500 milliseconds, now it's maybe a full 1,000 milliseconds. And because of that, now there's a larger window of time where the requests are making their way into Station API. And so you have more requests making it to Station API, which further is stressing out Station API. Our users, in this case, they're getting a little bit frustrated. It's a little bit of a long wait, but eventually they're back to normal. They're okay, right? What happens now if Station API is just completely overloaded, like that 3 o'clock in the morning PagerDuty situation that we had here, right? Well, now you have just a massive, massive window of time where from first cache miss until cache is filled, you're talking about 5, 10, 15, sometimes 30 seconds, and just all the traffic is hitting Station API, and that's really what's driving this kind of thundering herd pattern that we're having here. And our viewers, they're just mad, they're frustrated, and they're sad. So what did we wind up doing to mitigate something like this? Well, what we wound up doing was we took our Station Video Portal code and we updated it. So instead of caching this for an hour, or eventually we had updated it to 2 hours, we decided to cache it for forever. Just cache it indefinitely. And then we wrote a separate Django management command that will do that cache refresh for us. And we just put it on an ECS scheduled task. We put it on a cron job. And now this update is happening asynchronously. It's happening exactly once. And it's very, it's very fail-safe. If something doesn't work quite right, we'll just get it in another hour. That data does get updated from time to time by our stations, those donation links and things like that, but they don't change that often. It's okay if it's an hour out of sync. And what did that look like? Well, now, instead of having these big spikes of traffic and things like that every hour, every couple of hours, now it's a very smooth, easygoing traffic pattern over the course of an entire day. And so with something like that, you're getting much better scaling, much better performance. You're not constantly scaling up, scaling down, scaling up, scaling down. You're not flapping. So, from a technical perspective, we're super happy. But also from a financial perspective, we're super happy, right? Our Station Video Portal daily run rate cut in half, right? We went from, $9, $10, $12 a day to $3 or $4 a day, right? So the accounting team is loving us, and now that means that we can take a lot more of that money that we're getting from viewers like you and pour it into other more important things like programming and games for kids and et cetera. Shifting gears just a little bit, another thing that PBS is doing with CloudWatch is business metrics. So keeping track of not just is the application healthy, but are we providing a good experience to our viewers, right? So again, some background. PBS Passport is a membership benefit for our station donors. So if you're like me and you grew up in the 90s and you watched PBS and you'd see, with your gift of $50 or more, we'll send you this tote bag as our thank you for your donation. This is the 2024 version of that, right? By making a donation to your local station, you're going to get access to streaming the back catalog of many PBS programs. You're going to sometimes get early access to be able to binge an entire season of a show right the first week that it comes out, et cetera, et cetera. If a viewer makes a donation and then they're not able to watch those programs right away, they're going to be upset, right? I just gave you, $5 a month or $60 a year or however much I gave you. I'm expecting to watch this program that I really want to watch right away. So how do we keep track of this? Well, initially what we did is this data was already in the logs, right? Our application was logging, hey, here's a passport activation success. Hey, here's a passport activation failure. It's pretty easy to query for. We know what these things look like. So what we can do is just set up a metric filter and graph it, right? So we were able to very quickly come in and set up a metric filter and turn it into a CloudWatch metric. And now we can just kind of see over time, how many successes and failures and things that we're seeing. Failed already active is not necessarily a huge problem, but there can be other types of failures as well. Additionally, we did some other things like this with our login. So hey, login attempts and login successes and login failures. You know, somebody fat fingering their password isn't necessarily indicative of a problem, but if nobody can log in, of course, that's a problem, right? But there's some problems with that, right? So this kind of approach assumes that you are consistently logging things in your application. It is reliant on your development teams to make sure that they know where these things are happening, adding logging statements, keeping the logging consistent, following logging formats, all that sort of stuff. And it can be a lot of work. Enter transaction search. So this is a new feature from AWS and the CloudWatch team that just came out a couple of weeks ago. I'm very excited to be playing with this and diving in a little bit deeper. So how did we keep track of these passport activations in a new way with transaction search? Well, getting started, it's pretty straightforward. You go into the CloudWatch console, you go into settings, you check a checkbox, and you set a tracing index for what percentage of traffic you want to capture. In this case, I'm saying, yeah, catch all of it. And then you can go into that transaction search area and just build a query for this, right? So where the service is PBS org, and the status code is 200, and the operation is passport activate and the token that you use to activate your membership. Well, now we can graph that and get that same bit of data without any major application changes. We already have this app instrumented with application insights and X-ray and OpenTelemetry and all of that. All you have to do is check a box and start poking around in transaction search, and away you go. Now, with that, there's a whole bunch of future opportunities that we're going to be looking into with transaction search. For example, localization, right? So localization is a big deal for us at PBS. As we said, we have 180 member stations all over the country. When you log into pbs.org or you log into the app on your phone or on your smart TV or whatever, we're using the IP that you're coming from to figure out what most likely is your local PBS station that you want to view content for. So now when you fire up pbs.org here in Las Vegas, you get Vegas PBS content that's been curated for you. If I log in from my house out in Maryland, I'll get Maryland Public Television, et cetera, et cetera. We actually ran into an issue just a few years ago with a cell phone service provider who shall remain nameless, who, when they were building out their 5G network, they purchased a huge block of IPv6 addresses in order to handle all these extra bits of traffic that they're going to have coming in. Great. However, with all these databases that are out there that do geolocation based on IP, this particular cell phone provider just reported all of those IP addresses as being located in their headquarters location in Seattle. And so we, all of a sudden one morning, got a huge flood of reports from viewers. Hey, your app is telling me I am at Cascade PBS up in Seattle. I live in Missouri. What's going on? Why would you tell me that? So being able to just keep track and see those spikes in localization, sometimes they're not a problem, sometimes they are, but being able to kind of, instead of hearing about it from the viewer, being able to see that proactively and deal with it before the problem tickets come in. Another potential use case for us is our recommendation engine. So we have in a number of our apps and on our website just based on your previous viewing history, here's some titles you might like. It would be nice to be able to see how many folks are clicking through into, hey, I just watched a nature documentary and here's something else I might enjoy. Okay, great. It would be very good just to see what is going on and see if folks are using that recommendation engine. And finally, donation title tracking, right? So being a nonprofit that's mostly funded by viewers like you, pledge and getting those donations and those one-click donations in the various apps is a big deal for our local stations. They thrive on all of those dollars that you're giving them. So as a result, it would be great to just have a deeper visibility into which titles are driving those donations, right? That might inform making business decisions about what titles are we going to get in the future, or what sort of programs should we maybe air again, or what should we pick up for a new season, et cetera, et cetera, et cetera. So just to kind of wrap things up, CloudWatch has been able to provide us increased visibility into not just our applications and our application performance and how things are going, but also that business value that's there, those business metrics that can be super important for making decisions for PBS on where we should go in the future. So with that, I'll welcome back up Igor and Siva. And yeah, thank you for your time. I'll be available in the back, out in the hallway afterwards if anyone wants to chat.
Thank you, Brian, for such a relatable and exciting story for all of us. Thank you, Siva, for exciting us with in-action operations. And thank you all for coming here and sharing time with us. I hope you enjoyed the event, and hope you enjoyed our session. Fill out the evaluation form and have a great rest of your day.
Yeah. If you like what I had to say, consider donating to your local PBS station.